All right, let's talk about something called Simpson's rule. Simpson's rule is another numeric method to approximate an integral. So, similar to the trapezoidal rule, Simpson's rule will help us evaluate an integral maybe if we don't know the actual function, specifically a numeric method if we have maybe data in a table. Now, in general, let's review the trapezoidal rule. We have b minus a over 2n. So again, that's delta x, and then the 2 comes from 1/2 the height. And again, remember the height is delta x. And then when we see the function notation here, we've got basically we need to add the bases together. Well, there's the one base for the first trapezoid. There's the base on the left and the base on the right. For the second trapezoid, well, the base on the left is the right of the other one plus the base on the right. That's why there's two of all these bases in the middle and just one on each end. Now, Simpson's rule, it looks very similar, but Simpson's rule on each subdivision, like if we have some subdivision, Simpson's rule is based on doing a parabola area on each subdivision. It's a really neat proof if you want to just Google proof of Simpson's rule. It's very elegant, but basically it leads to this formula right here, which looks very similar to trapezoidal rule with a couple differences. One, at the beginning it's b minus a over 3n, and then that comes from finding the area of these parabolas on each subdivision. And the other thing is the coefficients. It starts with 1 at the front and ends with 1 in the middle at the end, but then in between it bounces back between 4, 2, 4, 2, 4, 2, and ends with 4, 1. So we have 1 on the front and the back, and then it goes 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, repeating until we get to the next to last subdivision and the last subdivision. And another caveat, and this is very important, for Simpson's rule, the number of subdivisions must be even. You have to do 4 subdivisions, 6 subdivisions. There's no such thing as Simpson's rule with 7 subdivisions because the numbers don't work out with the coefficients in the middle. So let's look at a specific example. Let's say we want to approximate the integral from this function, f of x dx, on the interval 2 to 10, and let's do Simpson's with 4 subdivisions. We've got 1, 2, 3, 4, 5 pieces of data, which leads us to believe that there'll be 4 subdivisions. Okay, so I know that I can approximate this integral as, I'm just going to write it out, b minus a over 3n, and I got one of these first things, actually which is 2, then I got 4 of these next things, I got 2 of these next things, and now I can end with 4 of those, and then 1 of those. So here's the coefficients, the 1, 4, 2, 4, 1. And the f, the value of the function, that gets the height. And we know b, we know a, we know n. So b minus a, so now let's just plug in what we know here. So this is going to be 10 minus 2 over 3 times 4 times 1, well, f of 2 is 10, 4, f of 4 is 14, 2, f of 6 is 20, 4, f of 8 is 22, and 1, f of 10 is 30. Well, this is 8 over 12. Here we have 10 plus 56 is 66. 40 more is 106. 88 more is 194. Plus 20, 224. And whatever that is, let's see. 224. Let's see, this is 2/3. 224 is not divisible by 3, so I'm just going to times it by 2 and get 448 thirds. Now, just use your calculator though. You don't need to work with fractions. It's perfectly fine to just type these in your calculator. That's a perfectly fine thing to do. And if you don't want this fraction, this is 140 something like that. Just use your calculator. But the idea is Simpson's rule will look a little different. The coefficients bounce back and forth. The data in the table will lead us to how many subdivisions there will be.